Hello and welcome to the second part of the presentation on artificial intelligence on data management. I am Pierre Bonnet from the Engage Meta community. In this session, I will present some use cases of AI and some interesting software to be aware of. I would like to remind you that the video from the first part is dedicated to our vision of information system architecture and data management for the deployment of AI on a large scale in businesses. It was in this first video that I introduced the TRADA framework. The content of this presentation is free to use, published as a Creative Commons, which means it is open source. You are welcome to reuse the concept text and illustrations as you wish, provided that you cite the source, which is the Engage Meta community. I invite you to visit our website for more information on our publication. My name is Pierre Bonnet, and I bring over 30 years of expertise in the field of information system architecture and data management. Here again, I invite you to visit the website of the community for a presentation of my expertise. Here is the content of my presentation. As you can see, the slide deck covers the two last chapters, AI impact on governance and AI software solutions. I invite you to review the first slide deck, which addresses our vision and our solution with the TRADA framework. You can find the video via our website on YouTube. I will begin by saying a few words about the impact of AI on professions. To avoid making this video too heavy, I will not go into detailed commentary on each use case. The content of each slide should be sufficient for you to independently read and understand. Therefore, please feel free to pause the video and also to download the slides directly from our website. I will present 13 use cases and feedback on the application of AI. We begin with the productivity. Here, I represent the way to develop software without AI, meaning with a requirement expression on developers who produce specific algorithms. It is a rather rigid and cumbersome process, but it is the reality of computing today. Even using agile development methods or no-code tools, you still must translate the needs into algorithms to be developed or configured. These set up the current states of software development and the challenges faced without the use of AI. Here's the mode of development with AI. There is no longer a need to develop algorithms or even write business specifications. I am exaggerating a bit, but basically, you just need to teach the AI what to do, and it will do it. Moreover, AI can improve on its own through self-learning, which is not possible with traditional algorithms. Even though not all use cases can be addressed by AI, it is likely that half of them will be, and others that were previously impossible to automate will benefit from it. The paradigm of computer development is changing profoundly, moving from coding algorithms to training AIs. We can envision a productivity increase of at least tenfold in software development. For example, in a team of 10 people who develop software in a traditional manner, AI could replace between 5 to 8 of them. The remaining team members will need to learn to work with AI. The others should focus on new use cases to create more added value for the company. If you think that you need a lot of data to implement your AI, you are mistaken. The following slides will explain why. Firstly, I must remind you that there is no good AI without quality data, regardless of the quantity. Thus, it's possible to have a lot of data and unfortunately implement poor AI due to bad quality. The more you deploy AI on large scale within your organization, the more you will understand the need for quality data and appropriate AI governance. This is the whole point of the vision I presented in the first part's video on the TRADA framework. In summary, you need both quality data and quality AI. So you need to have quality data, but not necessarily large volumes. Indeed, AI models like ChatGPT have already been trained with vast amounts of data of all kinds. You directly benefit from this. However, to meet the needs of your use cases, You must refine the AI by supplying your own data, like training datasets of a few dozen or hundreds of records, which is usually sufficient. You are then fine-tuning your AI. Pause the video to understand the process well, and it is quite straightforward to grasp. Of course, good fine-tuning requires following some best practices, such as consolidating certain guidelines to avoid providing the AI with the same information multiple times. For example, look at this slide on prompt factorizations. Please pause the video. Another mechanism for data injection into your AIs is real-time access to data sources stored in your own databases. Fine-tuning can then consider real-time data flows from your information system. On this slide, you can see access to a sales database using a technology called RAG for Retrieval Augmented Generation. You see that access to data is not just a question of volume, but of relevance and quality, including on small volumes. To better understand fine-tunings, I advise you to read a bit of the ChatGPT documentation. If you are concerned about the confidentiality of your data that you input during fine-tuning, it is necessary to study the technical documentation of AI that operate in the cloud, like ChatGPT. Here, this AI provides an enterprise mode of operation to address the confidentiality of your data. You can, of course, install AI engines directly on your infrastructure if you have concerns about data confidentiality leaks. Several solutions exist to secure data. For example, you can look at the Jan solution on this slide. Since we are discussing ChatGPT documentation, here is an interesting link to examples of prompt. You will be able to see the full power of AI in action. And to conclude this section dedicated to data, I am providing you with a link to an AI technology that aims to implement lighter AI engines, less resource intensive, and that require even less data to operate. The company is called AIZip. All the innovations that I have just reviewed in the previous slides are having an increasingly significant impact on organizations of all sizes, from solo entrepreneurs on small and medium enterprise to large groups. Let's now look at a use case for quality control of payroll sheet. The calculation of payroll sheets relies on multiple data sources, which I invite you to read on this slide. When these data are not clean enough, various cases of error appears, as indicated on the right. A traditional way to correct errors is to develop a program that executes verification rules. It is then necessary to specify algorithms and develop them. This is a heavy task with computer scientists. The result is rigid and does not easily adapt to new error cases. With AI, you simply provide it with your payroll error cases and explain the causes of their occurrences. Instead of precisely specifying the rules to be checked, you explain to the AI system the problems already encountered in natural language, complete with dataset. This involves providing the AI with knowledge about payroll, including data sources like emails and known activity information from project management tools, but also the regulation that must adhere to. This AI learning process is less costly than traditional software development. It delivers better quality and flexibility in controls. The AI system is also capable of instantly adapting to new sources of error through self-learning. Here I am comparing the cost we have seen previously. AI allows for a productivity gain of more than 10 times, both in terms of implementation costs and ongoing operations. In this scenario, we continue to use the payroll management software package to establish the payroll sheets, and we implement an independent AI system that checks their quality. It is a very powerful approach. Now let's look at the use case of AI for the analysis of regulation impact. Let's consider the case of the Basel III regulation in the finance world. The compliance rules are described in a regulatory document with successive versions. its documentation in the form of text and in natural language. Thanks to generative AI like ChatGPT, it is possible to directly provide the PDF file of the regulation to the AI system and ask it to generate a knowledge graph with the terms of the regulation and their relationships. The PDF file is thus translated into the form of a formal knowledge graph, onto which we can add interesting information for impact monitoring. In this example, I use the knowledge graph tool named TermBoard, and you have the link to it on this slide. This first part of the construction process revisits what I've just presented, that is, the injection of the PDF of the regulation and the generation of the knowledge graph. Now, a business expert in regulation adds links in the knowledge graph to the various components of the enterprise systems that are impacted by or related to the regulation. This is a formulation of the knowledge of teams responsible of applying regulations. It could also be a single person for small organizations or even directly the entrepreneur themselves in the case of small business. Ultimately, we obtain the RG1 reference graph that describes the existing situation for regulatory compliance within the company. Now a new version of the regulation arrives, and it is necessary to quickly and thoroughly identify its impact on the enterprise. Instead of manually reviewing all possible impacts, you simply generate a graph of this new version using the same process at the first time. This results in a RG2 reference graph, which describes the situation based on the new regulation. To obtain a comprehensive list of the impact of this second version of the regulation, you just calculate the difference between the two knowledge graphs, RG1 and RG2. Thanks to AI, rather than relying solely on the informal knowledge of the team responsible for applying the regulations, it is possible to build knowledge repositories to automate all or part of the impact analysis. These represent a significant gain in quality and time. Here's now a press excerpt of the use of AI to assist in the discovery of new materials. The article explains that AI is capable of accomplishing in a few hours a result that corresponds to an accumulation of knowledge of over 800 years to discover new materials. Some of these will enable the creation of new products. It is a technology that combines deep learning with graph management developed by Google. Now let's look at the use of AI for the creation of assistants. The concept involves matching a preference domain, such as favorite restaurants and price constraint, with the context when requesting assistance, such as preparing for a business trip. Preference domains are limitless. I invite you to read the slide for a quick overview. You simply need to train the AI system with your preferences in a domain, for example, by providing your 10 favorite restaurants. Then you can ask the AI to find the 3 restaurants closest to your preferences and located within a geographical area corresponding to your stay. This process is very easy to do with ChatGPT, for example. With several assistants customized to your needs in different domains, you can then combine them to move towards automations that are more or less sophisticated. For instance, not just suggesting a restaurant, but also a hotel and tracking reservations in your email box. If you need help organizing your various personalized AI assistants, there are various software options available, such as the one I mentioned here. I have not tested it, but it allows you to get an idea of the new world of personalized AI assistant. Another use case of AI is assisting with text writing in writing styles that you define. If you let AI write for you or correct your text without first educating it about your writing style, you will get results that do not resemble to your own work. To educate the AI system, you simply provide it with a series of writing examples, for example, text you have already written. You can also provide it with text from authors whose styles suits you. You then ask the AI to provide you with a prompt that describes the writing style that emerge from all these examples. About 10 examples should be sufficient. You use this prompt to generate and correct your future text. You can even plan a prompt for each type of writing, for example, for emails, meeting minutes, or analysis report, slide, etc. Here's another example of AI, this time for the generation of computer code. As you can see in this figure, several AIs are used in the software development process. It begins with Anthropic, Claude, which seems to provide very relevant results in generating code for training data on a textual description of a requirement. The code generated by Claude is then integrated into the Replit integrated development environment to adapt the code. ChatGPT is then used to obtain an explanation of the code generated by Claude and to debug problems. The different AI systems are thus used according to their abilities to solve certain parts of the software development process. It is a chain of AI systems, a kind of ecosystem where AIs collaborate. In the field of data quality management, one of the challenging problems to solve is data deduplication. Let's see how AI can help with this. AI receives descriptions of data in the form of database schemas and data instances, datasets, along with informal descriptions of the data flows exchanged between systems. The AI's role then is to create a knowledge graph of data elements and their relationship. For example, a customer record is split into as many links, relationships with other data, some of which may be suspected of being duplicates. This graph can then be manipulated by both a human and the AI to detect potential duplicates and make deduplication decisions. In this process, the AI is thus coupled with a knowledge graph-oriented database. Here's a small academic example with ChatGPT directly. Here, I ask the AI to provide me with a dataset of 200 clients so that I can conduct my test. Next, I ask the AI to remove duplicate records based on only the main name of the clients. Feel free to pause the video to read my conversation with the AI systems. Note that I have activated the data analysis module in the ChatGPT options. Of course, the few examples we have just seen, along with information in the press, clearly indicate potential consequences for the employability of certain professions. Here's a rather radical example. This is about the French subsidiary of the international company Onclusive, which works in analysis and monitoring of information on the internet. In this article, they announce the elimination of 57% of their workforce in France to implement AI. Depending on the profession, AI will replace a part of the usual workforce, and the remaining workers will need to collaborate with AI systems to enhance their creativity and productivity at work. All industries and all professions are and will continue to be increasingly impacted. A couple more public examples, for instance with Amazon. This press excerpt discusses how Amazon is leveraging robots and AI to streamline warehouse management and supply chains. Given Amazon's substantial human workforce, replacing a significant portion will have considerable consequences for Amazon's profitability. Immense productivity gains are expected due to AI and robotics. In terms of automation, here's another example involving the use of AI to manage an information chain on the internet. This is about Channel One, whose presenters are AI avatars. The viewer of the channel can choose their favorite avatar and configure their news preferences. The text, videos, and presentations are entirely automated by AI. Managing Channel One, as opposed to a traditional team of journalists, is undoubtedly 10 times less costly. This is a revolution in the field of information broadcasting. Finally, to conclude with the examples, here's what Bill Gates predicts. The impact of AI on workplace productivity will change humanity's relationships with work. Bill Gates believes that we will work only 3 days a week, and perhaps even less in certain professions. Feel free to pause the video to read his analysis. The link to the complete article is provided. Now we are going to look at the impact of AI on the information system, which refers to the applications on databases that companies use to carry out their activities. We will examine 4 different technical aspects: the architecture of the information system, managing prompt with the semantic layer, detecting hallucinations, and a synthesis diagram. Let's start with the impact of AI on the architecture of the information system. I've already discussed this in the first video of this presentation, which I also invite you to watch. Here, I will just provide a few quick reminders. First of all, it is important to remember that the large-scale deployment of AI requires high-quality data. You need to not only master AI, but also prepare your information system to provide it with high-quality data, both from structured databases in terms of general knowledge management, like unstructured data, information in the broader sense. AI cannot produce a transformative and positive effect on a company's activities without good data and knowledge management. Unfortunately, data management is rarely well mastered in companies. It is often penalized by siloed activity management, which does not promote data quality. Let's see more about this in the next slide. Here you see a classic representation of the information system in the form of silos, meaning applications on databases that are vertically aligned with functional processes. Each silo tends to duplicate processes and data, which leads to significant problems with synchronization on the quality of management rules on data. With a silo information system, it is difficult to see how AI can integrate reliably. When AI algorithms are added for automated decision-making in different silos, serious problems arise, which I have listed on this slide. Feel free to pause to read them in detail. In summary, the reliability and traceability of decisions made by AI algorithms are unpredictable due to the lack of quality in data and rules. In other words, the enhancement of the information system intelligence through AI depends on its initial quality. An information system that is poorly structured from the start cannot benefit from good AI. Worse, this system will become even less intelligent with AI systems. Some positive contributions within a few silos may be possible in the short term, but when seeking coherence on overall integration of the silos, a collapse of AI will become evident. Now let's see how to correctly integrate AI across the information system. First, it is necessary to create a semantic data management layer for the most important rules and processes to escape the complexity of the silos. This involves creating a kind of digital twin of the information system. This twin synchronizes with the silo to maintain up-to-date data. Technically, as I've already discussed in the first part of this presentation, this involves setting up a knowledge graph-oriented databases to formalize business concepts with their ontologies and then accumulate the knowledge necessary for AI. The entire setup is subject to appropriate enterprise governance. AI algorithms interact with this semantic layer rather than being directly connected to the silos of the information system. The AI then relies on higher quality data and benefits from the knowledge that is accumulated both individually and collectively. Once well mastered, the digital twin of the information system can itself evolve to influence changes in the information system, generally with the idea of gradually reducing the silos. In the long term, it's the information system that will become the digital twin of the semantic layer. The evolution of the coupling between the semantic management layer and the information system describes a trajectory for the progressive redesign of the information system to eliminate the problem induced by silos. This is a movement that is necessary for large-scale deployment of AI. In conclusion, we revisit the overall diagram already discussed in the first video of this presentation series. On the right, you see the digital twin acting as an abstract representation of the information system to shield the technical complexity from the AI. On the left, there are AI algorithms connected to the semantic management layer to ensure effective AI governance. At the bottom of the figure, there is integration with the organization for both the accumulation of individual knowledge of each collaborator and the collective knowledge of the organization. Finally, at the top, there is an independent AI separate from the AI algorithms integrated into the information system. This super AI system ensures a general governance of the enterprise system's behavior. As I've said before, by injecting AI into your operations, your enterprise system will increase in intelligence. The stronger this intelligence becomes, the more it requires another independent intelligence to monitor it. This is the idea of AI-powered governance, the nerve center or second brain in our vision, and therefore in this synthesis figure. Feel free to pause the video for a complete reading of the various definitions. Please feel free to pause the video for a complete reading of these 3 use cases of the knowledge graph management technology, which serves as a foundation for the semantic management layer. Firstly, as a storage area for business concept and ontologies. Secondly, as various tactical repository for knowledge management, particularly for managing regulations. And finally, more generally, as a repository for storing and accumulating the knowledge of actors on the organization. Now let's see how the semantic management layers assist in the proper management of prompts. In each prompt, the goal is to identify the business concepts used to create the ontologies. These business concepts are also linked to the time management and geographical concepts. On this slide, you can see that the prompt formulated in natural language by the user refers to 4 business concepts: customer, purchase, warehouse, and stock, as well as a geographical concept with location and a temporal concept with time. Thus, there is a correspondence between the natural language prompt and the ontologies managed in the semantic layer. The process for handling the prompt is as follows, based on the number presented on this slide. 1. The user formulates their request in a natural language. They can be assisted with the use of prompt templates or by direct access to a catalog of business concepts known in the ontologies. I will revisit the example of the Palantir solutions in the following slide. 2. The business concepts identified in the prompt are used to launch a query in the semantic database to retrieve information to enrich the prompt. 3. These result in a super prompt enriched with business concept, often referred to as fine-tuned prompt. 4. If necessary, the business concepts are also used to consult real-time databases containing live data that have not been previously used to train the AI. The technology used here is called retrieval augmented generation. These 4 steps are integrated into a query composer type model that enriches the base behavior of the generative AI. Without these steps, the large language model works only on data used during its training. With the semantic management layer described here, the LLM is augmented with information retrieved from the semantic repository. These are additional data sources to those used during AI training, enhancing the quality of the prompt and its data context. In the following slide, I revisit the example of the Palantir solutions already mentioned in the introduction of this presentation, the first video. It illustrates well this integration between AI and the semantic management layer. In this slide, you have some screenshots of the Palantir solution for creating prompts. Here, the prompt writer directly integrates the business concept described in the flight table. This table is part of the ontology managed in the knowledge graph-oriented database of the Palantir solution. Another interesting aspect of the semantic layer is its ability to detect certain hallucinations that generative AI can produce. The principle of coupling the large language model with the semantic layer, as we saw for prompt construction, is similar for analyzing the AI's response. As shown on this slide, the LLM response, step 2, is a text that undergoes analysis to identify business concept, enabling a check of the LLM response with information available in the ontologies on other databases, for example, data coming from the RAG mode during prompt construction. This is step 3 on the slide. Finally, in step 4, it is also possible to ask the AI to self-evaluate its response and to identify its own hallucinations. A specific prompt for this request is then formulated. Of course, it is not possible to automatically detect 100% of hallucinations, but it is generally possible to ensure that there are the parts of the AI's response based on fact verified in the ontologies and in the dataset access in RAG. For example, the software solution Able offers this kind of hallucination verification. In the following slide, I will provide a link to the company that markets this solution. Here is the link to the company Airtable. Now let's see a synthesis figure that summarizes the architecture underpinning our vision for large-scale AI deployment with associated data management solution. Here's the final version of the blueprint with all the components: master data for data flows, operational data store, master data management at the level of the enterprise, knowledge data store, business object data as a product, AI enterprise governance, and AI-powered automatic governance. With this blueprint, you can now better plan your digital transformation journey from an architectural perspective. In summary, I would like you to take away 2 key points from my brief presentation. Firstly, modern information system architecture should be built on a foundation of semantic management. This means having the ability to work with semantic models to support the 5 crucial components of the information system architecture I've just described. MDM for data flows, operational data store with data fabric, MDM enterprise, knowledge data store with knowledge graph database, and the data business domain with data mesh. Secondly, it's essential to emphasize the integration of artificial intelligence through AI enterprise governance, which is connected to the semantic management subsystems on LLMs such as ChatGPT. Additionally, we need AI-powered automatic governance to maintain control over the complexity of the new intelligent information system. All share the same glossary, taxonomy, and ontology. This is the key point to reach success in digitalization from an architecture perspective. Now let's address the question of enterprise governance with AI. Enterprise governance comprises a set of practices designed to manage organizational risk appropriately and to ensure the responsible use of a company's resources. It includes regulation compliance, like corporate social responsibility, environmental and social and governance, industry regulations. By recognizing that the code underlying AI and data solutions can carry the wealth of governance, executives can appreciate the role these technologies plays in reinforcing governance structures and ensuring that organizational activities align with strategic objectives and regulatory requirements. In other words, by reducing manual processes, the risk of non-compliance in daily operations is minimized. In the Trada framework, we have the Enterprise Governance Green Card with 4 topics: data governance, AI governance, regulation compliance, and AI-powered governance. Please pause the video to read all in detail. Now let's have a look at enterprise architecture on AI. Enterprise architecture is a body of practices to improve the documentation and understandability of any business system. The business system is the set of principal practices and procedures that are applied to specific activities to achieve a specific result. EA is based on a business architecture with the processes, the data architecture with the logical and physical layer, the application architecture with software and rules, and the technical architecture with the infrastructure and security. In the Trada framework, we have the enterprise architecture of the green card with these topics: semantic modeling, to manage ontology, service-oriented architecture and microservices, and conventional EA framework. I'll let you pause the video to have a detailed look at the content. Now I want to give you an overview of our possible services. Here's the list of possible services that we offer to delve deeper into the subject I've just presented. Rather than reading each one, I prefer to let you pause the video for a few moments. Finally, to conclude, you now have a series of slides with AI software that we find interesting to study. I will just scroll through each slide and name the tools. I invite you to visit the websites of these companies according to your interest. AI Academy is a partner of Engage Meta community and provides the market with various AI solutions, including an AI governance platform. Hebel Company provides an AI governance platform with Hallucination Check. Claude from Anthropic provides a LLM, especially for code generation. Replit is a software engineering tool with AI. Teamborn is a knowledge graph database on LLM integration. Stardog is a knowledge graph database. Neo4j is also a knowledge graph database. Astranodus is a knowledge graph database integrated with LLM for knowledge accumulation. Entry.ai is a AI governance for training data on prompt fine-tuning. DNetRAS is used to monitor, analyze, and optimize application performance, software development, and security practices, IT infrastructure, and user experience. AIZip is a tiny AI engine based on LLM fine-tuning. It is used for the creation of flexible AI engines based on the large language models. Palantir provides an AI governance with ontologies based on the knowledge graph database architecture. Hugging Face is the hub for AI solutions dataset and various tips in the field. Jan is a company that provides the market with AI for desktop. Perplexity is a search engine solution based on AI. Agen is an AI for generation of videos avatars. Eleven Labs is a solution for AI-generated voice. Thank you for your attention, and don't hesitate to contact me and follow me on LinkedIn.